Alright folks, today we're going to talk about trig regressions. That word should be familiar from Chapter 2. We did a bunch of it. We fit models of equations to lists of data. And we're going to do it with sine and cosine equations today because they have a lot of application in the natural sciences especially. So what I need you to do before starting today is make sure you have a graphing calculator. And we're going to talk about this list of data that you see on your paper here first. It has a table that's organized into D and N. And it says the data shows the number of N hours of daylight in Jacksonville, Florida, as a function of the number of days after December 31st. So as we look through here, this would mean 1 would mean January 1st of that following year. The 32 would be February 1st of that following year, and so on. So let's go ahead and label these: January, February, March, April, May, June, July, August, September, October, November, December. But hopefully you noticed there were two sets of these D and N variables. That's because right below here, 366, that would just be still the 1st of January, but the following year. So they've got 2 years of data here for us to look at. Now, what we're going to do is talk about these trig functions, and I said only sine and cosine because the shape of a wave is what's going to happen more commonly. If you notice through the table here, our starting value is at 10.23, and it gradually increases up until 14, and then it goes back down again. Then our second row for our second year does kind of that same thing, and your numbers straight up and down look a lot like the same value for most of the entries. That's what makes it a sine wave, is we're seeing that repetitive motion. It goes up and then down and then up and then down between a maximum and a minimum value. What we're going to do is go ahead and put this in our calculator to graph those points, see physically the plotted points for the wave, and then answer some questions about it. So on your calculator, just a reminder, when we're trying to get to our list, we're going to hit Stat, and then that Edit button is where we need. And you should have these List 1 and List 2. If you don't, if you do Stat and Setup Editor, that'll bring them back. Okay, but with this, we want to make sure that our lists are cleared out. Now, I've already typed these in, so I'm going to show you with List 3. If you want to get rid of all the stuff that's in there, just highlight the list you're trying to clear out, hit Clear, Enter, and you're good. Okay, it's been a while since we did that, so I wanted to refresh your memory on that. Okay, but just to point out here, we're putting all of the days in List 1, and all means all 12 entries for the first year and the 12 entries for the second year. So as soon as you finish that first row, you're just going to start with the second row of days past that. And then same thing with List 2, so you should have 24 numbers in each list. Okay, pause the video and take care of it. It's important that you follow along so you know what you're doing for your homework. Okay, once that data is typed in, what we're going to do is make a scatter plot, and for that to show up, we have to turn our plots on. So second y equals. This first one, we just want to hit Enter, and hit Enter on the on so that it turns on. Then the second thing is just the type. You want it with that scatter plot highlighted. You shouldn't have to change that. And then List 1 and List 2. If for some reason your calculator is not on List 1 and List 2, hit second 1 for List 1, go down second 2 for List 2, and you're good to go. We want to make sure our calculator has a good window to make sure our points show up, and there's a built-in function under Zoom, so go ahead and hit Zoom. And then if you scroll down after you hit Zoom, all the way to number 9 was what we used for our plots, Zoom Stat. So Zoom 9 from now on, we don't have to scroll. Now you'll see the pattern of the wave here. You won't have any curves show up. Just in case you do see something, and obviously mine has an equation in there, let's go to the y equals, and anything that you had in there from previous problems, go ahead and clear out for right now. We'll talk about how to get the equation of that curve here in a minute. Go ahead and go back to graph, And all of your points should fall in this curve. If for some reason one of them doesn't, you'll be able to see if it's at the first 12 entries or the second 12 entries, and if it's the x value or the y value messing it up, and you can go fix your table based on that. So if you don't see this big M, pause the video and go double check your numbers. But for us, these do make a sine wave like we were talking about earlier. Okay, so that's the answer for the first question. And why it's on here really is so I can talk about this word right here. When you see wave on your homework, it can mean sine, but it could also mean cosine. Okay, so when the word wave is there, it just means I'm using them interchangeably. Both of them are sine waves, but the parent function could be sine or cosine, and that usually is your choice. I say usually because our calculator is always going to pick sine for the parent function because that is the built-in regression model it has. So what we're going to do is go ahead and calculate that regression model for part C here, and we're doing it the same way we did the other ones, and that's by clicking Stat, going over to Calculate, and all of our regressions are down here. Okay, we don't know the shortcut for this one yet, so I just need you to scroll. It's actually closer to the bottom than the top, so if you go up, you'll get there faster. But we're looking at the sine regression. So you can hit alpha and then C if you want for the shortcut. I'd rather just scroll up because it's really close to the bottom there. Okay. When you're dealing with this next screen, you're going to leave that first thing alone. Just double check that your list 1 and list 2 are there. Again, if they're not for some reason, second 1 and then second 2 to get those there. And we're just going to go down and hit enter on the calculate. Okay, you shouldn't have to adjust any of those things as long as it says list 1 and list 2. It gives an equation here, and the formatting's a little bit different from ours. So what I want you to do for me is go ahead and write this on your paper for me, just to the side where I have it. That's going to make sure that we write all of the numbers that were given from our calculator in the correct order. So first up here, we've got the A value, and that is the 1.913. So we'll start with Y, but instead of equal, approximately, because we're going to round. Okay, I said 1.913 because we always round regression models to 3 decimal places, so we're going to stick with that. Okay, from there, we're using the parent function sine. Again, your calculator always will use that. Then in parentheses, just bx plus c. So this is already distributed through. We're not going to do any extra parentheses than we see. 0.017 x plus c is just minus 1.386. Close it, and then on the end we're tacking the plus 12.173. Okay. Then we'll use the numbers in our equation and recognize them to interpret what the amplitude, period, maximum, and minimum of the equation are, because a lot of times with word problems they give us context that's important. So, first up, you want to look at your note card to find out our formula and how it looks a little bit differently. I'll go ahead and write it down here, but take the time to grab that note card so it's handy for us for the rest of these problems. So b sine, and then 1 over a, x minus h, plus k. The amplitude we call b, but it's still just the number in front, so we're using that approximately 1.913. The period deals with the a value. It's the reciprocal of what we see here. We're doing the same thing when we talk about this one. We have to do the reciprocal of what we see here. But that's why I had you write down this formula, because it looks a little bit different. So I want you to write 2 things on this one. First, we know from our note card we're supposed to take 2 pi times a. But we know from this equation, a isn't the same. So we're going to replace it with what we see here. Both of these things we want to reciprocate the number. But instead of using a, they use b. So we're going to just take it times 1 over b. And that's actually built into our calculator now that we calculated the regression model. So we'll type it in using our calculator's memory. So back to our calculator, you can get out of this screen, second, quit. And we're going to type what we see, 2 pi first, and then times 1 divided by, and we're going to find b in our calculator. So it's been a while, but VARS stores all of that saved data, and it's under statistics because that's what we did to find the regression. And lastly, go over to equation. All of the letters from that equation are right here. We're grabbing b. It is important that you use the letter B versus the decimal, and I'll show you the reason. So this is the number using all of the decimal places that was 4B from our equation. If we only use the value from our rounded version up here, that would look like 2 pi times 1 divided by 0.017, and our number is pretty significantly different. So we do want to be careful to use that from our calculator. Okay, so make yourself a note here. This is in VARS. All right, but with that number, we want to give it some context. I said these things deal with what's going on in our table. So our x values are days, and notice they're rounded to whole numbers. And then our n values are our y, and they are rounded to 2 places. We'll stay consistent with that when answering these questions. Okay, I'll come back to talk about the amplitude because it's one of the least context relevant items from this list here. So back to the number we saw. This is an x value since it's left and right on our graph, so we're going to round to a whole number and use the closer one to the exact value, so we'll call it about 366. Now that should make sense to you because that represents pretty close to a year. Maybe a leap year there, but that's our period or how long it takes on our table to start repeating itself. Okay, with max and min here, we can use our VARS again, but I want to remind you of the process. So maximum and minimum are affected by the amplitude and the vertical shift on the graph. So we want to do positive and negative our amplitude value, and I'm just going to write the regular numbers for right now and see about with our VARS as well for this one. Okay, max we're going to use the positive number, minimum it's the negative, because usually when we're talking about sine cosine it goes 1 to -1, but that's based on the amplitude, so we're using 1.9, -1.9. Then translation up will change that, and we'll just add that number to each of them. Okay, so again, in our calculator here, we can use more than these numbers given by using the letters that are built into our calculator, but on this one it's actually not going to matter, and the reason for that is with rounding. So because we're just adding these, we're not dividing or multiplying, the decimal places, if you add 3 decimal places to 3 decimal places, usually shows at least 3. Well, with our table, we only have to round to 2 decimal places, so we shouldn't have a problem. Let me show you that with our numbers. So first up, 1.913, this is the rounded version, 12.173. We would call that 14.09 because we want to round to the same thing as the table, and that means hours. Well, in terms of VARS, what that does instead, so I'm going to statistics and the equation, I want to use the amplitude, so they called that A, so I would say A, and then I want to add the K value, and for us that is D with the equation. So again, VARS, stats, equation, down to D. If you look at this number compared to this number, yes, they are different, but they round to the same thing in terms of the 2 decimal places. So you don't necessarily have to use VARS for this one. You do have to use VARS for the period. Okay, it's going to make a difference. Minimum, because we don't have to use VARS, we're not going to, -1.913, and then plus 12.173. And this says exactly 10.26, but remember we rounded those decimal places, so it's still approximately. Okay, so if we compare these numbers to our table, it says the highest number of hours of daylight is 14.09, lowest is 10.26. Going back here, there looks like the maximum, and the minimum is this 10.23 that we see at the beginning. So pretty close to what's given. We do go higher than the max from the table, and that's okay because we're only measuring the hours of daylight one day of the month. So of course other days of the month can go higher or lower than that. It is a little bit more strange to see that our actual minimum is lower than what our table or what our model predicted. Okay, not perfect, but we do realize that regression models have some bit of error with them. All right, so going back here, the amplitude, since it's a y value up and down, is also going to be talking about hours. We can hack off this extra decimal to be consistent, but really this tells you how much you fluctuate from the average. So it's 1.9 above the average and 1.9 below the average is where you find the max and the min. Again, not a lot of questions are asked about that in terms of context. Okay, so I'm not as worried about you rounding correctly or labeling with the amplitude. On part F here, it says, what is the calendar day on which the number of hours is the greatest? This is where we're going to actually use our equation on our graph to actually trace the maximum, okay, because we're looking for the greatest number of hours. So go to your y equals for me, please, and we're going to paste in the equation using vars like we did for the period. So hit vars, still statistics, but when we go over to equation, we're just using that first thing, hit enter, and it pastes in the entire equation. Then when you go back to your graph, you should see this curve. Remember, anytime you don't see a curve when you type in the equation of sine and cosine, your problem is probably your mode. Okay, we're good here. We're going to trace the maximum. It does say for the first year, so we're looking at this first one. Second, trace the maximum, number 4. And you just want to get on the left-hand side and the right-hand side of that highest point. Okay, so I'm moving along here. Left side, enter. Right side, getting around over there, enter. And one more time makes it guess where the middle point is. So we want to know the calendar day. First, we're going to start with the day they give us as a whole number. And this is 172. In general, this is a round down situation because even if that was 172.9, it's still in the 172nd day. So we're rounding down, but then we just got to transfer that number to a calendar date. So we want month and day. We'll go back to our table and figure out where 172 falls to do this. So at the top, right between 152 and 182, remember this 152 is June 1st and this 182 is July 1st. So July hasn't happened yet at 172. We're just going to take this number and use it. So process for this in general, subtract off that one right before it. And the number gives you the days after the first. Okay, and I'm going to have you go ahead and write that. For us, this was June 1st. So 20 days after June 1st is June 21st. And that'll be the process for that. On that day, going back to your calculator, it's 14.09, and that makes sense because our maximum was that number. Right, then it says how many hours of daylight does the model predict for January 1st for the next year after the data shown. So after the data shown means after this 700, but we do want the 1st of January, not the first day after this. Okay, so we got to think about what's happening here. 1 year, they're calling 365 days. Let's assume it's not a leap year. So we're going to get back to my screen here. We're going to take the 2 years. We know 365 in 1 year, multiplying it by 2. But then we want the day after that, so we will add 1. Okay, from there, we just have to trace it. Remember x values in your calculator, and let's go ahead and write that. This is an x value, just like this one was. An x value we can just trace. Once you hit trace, though, the plots are going to pop up, and we don't want to trace our points. We want to trace our curve. So go up, and then we can type in that 731. So it looks like 10.29, rounding to the same thing we have been. And if we look at our table, we had 10.23, 10.23. We would expect 10.23. We got a little bit higher than that. And sometimes that happens with a little bit of error, again, because our regression models aren't perfect. Now, that's technically all that's new today, but we're going to review a little bit on some word problems because we need some more practice with those. Okay, in general, even if it's not a word problem, our first process when we see a graph should be mark the maximum, mark the minimum, because that allows us to find what we need to write an equation. This one is talking about a pendulum swinging back and forth, and it's measuring the distance from an object based on where the motion detector is. Okay, so we're swinging away from the motion detector, closer to it, away, closer to it, and so on. You'll notice we're always 1 meter apart, so it's not swinging and actually hitting your motion detector. Okay, so our maximum here is 1.5, and our minimum is 1, and the reason that's important is because when we're talking about writing an equation, that's what it wants us to do, we need to know A, B, H, and K from the note card. And this thing in the middle I just pointed to is your K. It always cycles around that middle value. So let's go ahead and lay out A, B, H, and K and fill in what we know. So based on our numbers 1 and 1.5, the middle is 1.25. Okay. Then we're also going to look at the amplitude at this time, and that's just the distance up. So we knew the middle was 1.25. We're just finding the distance between those, or 0.25, for the amplitude. Next thing we want to do is look at the A value, and in general this is the hardest thing to see on a graph or to determine, but it deals with the period. So I want you to add one more thing here, just the period. Usually when you're trying to figure out a scale, it's easiest to start at 0 right on the y-axis. We know the period is from maximum to maximum or minimum to minimum, but if you use 0, the starting point, whatever it may be, you'll be able to see directly on the scale what the period is. So what we want to do is start tracing this curve and ask ourselves, when do you start repeating the pattern? So the first thing I do is go up, and I just want to figure out where am I in the middle going up. So I'm going up around, and right now I'm in the middle going up again. So there's my next spot at the same height. That's important. And if you look back or to the bottom here, the distance there is 2. So our period is 2 seconds. We're going to use that to solve for A because we know the period is 2 pi times A for sine and cosine, which look like the wave. And all we have to do is divide by that 2 pi to solve. So over here goes away, and then on this side we can reduce to 1 over pi. Word problems a lot of times are going to have a pi value in the A because the period usually looks like a normal number. Great. I'm going to come back to H based on what parent function we decide on. Okay, so our max and min are still drawn on there. I erased them for a minute to talk about period. But where you start, again, is going to tell us what we want to think about. So we want to compare this y-axis to where you normally start. For sine, it's in the middle, and for cosine, it's at the top. So for us, we're already in the middle. If you're already in the middle, we're going to call it sine and not have an h value. If you wanted to do cosine, you would have to figure out where this point is. And all you would have to do to find this distance is take your 2 and divide it into 4 little sections. Okay, your scale doesn't tell you that, but your period, and we know something important happens every pi over 2 normally, well, that's a quarter of the period. Again, make your life easier. Start with the easiest h, and that's just not having one for us. So y equals, we're going to note card to fill this out. Amplitude comes first, 0.25. We decided sine, so we're using it. Then remember, on the inside, we're doing the reciprocal of A. So I see 1 over pi, I'm going to write pi. Then normally we would put parentheses to put x minus h, but because we don't have one, we'll just put x and close it. And then last thing, we're adding k, which was 1.25 for us. And that's it. Last problem here, another application we've got is an oven. Okay, so when you set a temperature, and that's for an oven or that's for your thermostat at home, how it works is the temperature you're setting it at actually isn't the constant temperature in the oven or in the room. Okay, the heater or your oven's heating element is going to kick on and then kick off to regulate the temperature, because in any enclosed space it'll get really hot. So it has to kick off and then it'll cool down and then repeats that cycle. So again, anytime we're repeating a cycle, we have a sine wave that's happening. And it tells us for this oven, we're going to set at 425, and you can see that in the equation here. And it wants us to talk about temperature T, Fahrenheit in minutes. Let's go ahead and talk about this 6. It said that the temperature is going to fluctuate. This amplitude is actually giving us that because we're going to go 6 above and 6 below. This 0.9 we're going to talk about here when we relate to the ABHK values. But first up, it asks us for the maximum and the min. So just like we've done before, instead of using 1 and -1, we're going to use 6 and -6 based on whatever your amplitude is. But then this K that they gave us gives us our shift, or really what we're cycling around. Remember, K is the middle. So our highest temperature is 431 degrees Fahrenheit, and our minimum temperature is 419 degrees Fahrenheit. Be sure you go in the order they give you, otherwise label them for me. Then we want to find the period. Again, that deals with A, it deals with this number. What I would encourage you to do, so we don't have to worry about weird decimals, think of this as 9/10 m. Okay, that tells us that A is the reciprocal, or 10 over 9, and to find the period, we just multiply that by our 2 pi. So 20 pi over 9, but this one has context. It's talking about minutes, so let's go ahead and change that to a decimal, because it doesn't make any sense to talk about 20 pi over 9 minutes. No one says that kind of thing in real life. And about 6.98. Now on here, it really doesn't matter what you round to. I rounded to that for convenience, so it wouldn't round to a whole number. But honestly, if you wanted to call it 7, that's good with me too. It did not tell us any rounding information. Okay, so we want to talk about what that means in terms of the oven and its temperature. Okay, so remember, on a graph, you can find the period, I'm going to go back to here, from any point and where it starts repeating itself. Most commonly, we use maximum to maximum. So for us, with this oven, our maximum temperature was 431, so we're saying it takes about 6.98 minutes for the oven to cycle from 431 degrees Fahrenheit back to 431 degrees Fahrenheit. So it goes high, or goes lower to the minimum and back up. And you can use 431, you could use from 425 through the max and min and back, or you can use the minimum 419 to 419. It really doesn't matter there as long as it's a full cycle. That's the real important part. Then on this last one, it says Bernie purchased a different oven, and the manufacturer claims that less heat escapes from this oven than from the oven above. So that would mean that your oven would preheat faster, okay, because the heat isn't escaping. But also, it says Bernie's oven takes twice as long to cool from the max to minimum temperature. Okay, if heat isn't escaping, then it'll take longer to cool down if your door is closed, right? So it says, write an equation to model Bernie's oven based on our last equation, since we're going to use 425 again. So we just decided by that this 425 stays the same. Now, the 6 is based on the temperatures it fluctuates around, so that's not changing either. The only thing that's going to change here is the 0.9. Okay, so let's go ahead and write what we do know, and we'll just leave out the 0.9. So, let's chat. Twice as long to cool from maximum to minimum would mean it'd be twice as long for the maximum to maximum as well. Okay, and what that means is the period is 2 times as long. Now, we can mathematically solve for this, but it's a lot easier to just think about relationships between the period and what we see in the equation. So remember, the period up here was calculated by taking the reciprocal of what we used in the equation. We didn't use the 9/10, we used the 10/9. So if the period here is doubled, what we need to do the equation is the reciprocal of that. We need to half it. So the original number was 0.9. All we have to do is take half of that and get to 0.45. Okay, if that makes sense to you, that's all you have to do. Okay, how you would calculate this by hand is if the period is twice as long, you would use 40 pi over 9 and use that to solve for A. Okay, remember we're dividing by 2 pi. Fine on this side, not fine on this side. We'll call it 1 over 2 pi. Then we can go ahead and reduce. This is 40 divided by 2 is 20 over 9. This would be the A value. So 9 over 20 would go in the equation. 9 over 20 is 0.45. Okay, so you can do the math for it as long as you remember to reciprocate. Essentially, you have to reciprocate twice to be able to get back to the final answer. Sometimes using the common sense way is better in terms of it gets you there faster and it's less confusing for all the reciprocals. Okay, but if you do struggle at all on your homework, be sure to come in so you can ask some good questions.